So we have, wait till it starts. Oh, it did. I started with K instead of OK. That's different. I'm being a rebel without a cause today, starting differently. We have state the coordinates of the image of the point -3, 5 under the transformations. So I want you to give me the image points, but what I also want you to do here is I want you to state the transformations. So horizontal translation, blah, vertical translation, blah. Okay, so you're going to try these two out, see if you remember. This is mapping. So for mapping, when they give you directly, they give you mapping. Mapping and words are the same, right? Because mapping is just another way of displaying the exact same thing over, correct? It's literally just another way of showing that you're taking the y's, you're moving them up 4. You're taking the x's, you're moving it left 7, right? Like it's literally showing you it, mapping and words are the same. So if we did the transformations first, we'd have a horizontal translation. Seven left. And a vertical translation. 4 up. When we do the mapping, we already were given the point, so it's nice. Now we have to make sure that we read it properly. So this one says state the coordinate of the image of the point -3, 5. So they're asking for the transformed one, the image one. But what if they had given me the transformed one? And they wanted the original. How do you go back? You just undo it, right? You go 7 right and 4 down, right? You undo what you did. Okay? So, you get -10 and 9. We're not undoing it this time because they gave us the original, right? But you have to watch on the diploma because they sometimes give you the image, the transformed point, and you have to go back to the original to read thoroughly. Okay. This one, we have a horizontal translation. Six left. And a vertical translation. 1 up. So we do -3, 5, arrow. Remember, we need that original point, arrow, new point, right? That's how we show mapping, if they ask us mapping. So -9 and 6. Number 7 says, describe how the graph of the second function compares to the graph of the first. Now this is the key thing you have to watch. Anything that was on the original doesn't affect it, right? So for example, this is all in the original, so this is the only thing that's new. We agree? So we're going to have a vertical translation. 3 up. Now this one throws people off. They try and say 3 down. Can we say 3 down? It was already 3 down for B. Look, the 6 was already here, 6 was already here, 3 was already here, 3 was already here. What's the only thing that changed? The x minus 1. So it's a horizontal translation, 1 to the right. That's it. Because it was already, this original graph was already 3 down, it's still 3 down. I didn't make it any more down. Okay? And if you did make that mistake, I would start and say, remember to only write the ones that actually have changed, right? Because most people fall to that. Does it matter if this is an absolute value function? No. The brackets are just like the absolute value signs, right? It's the same thing. So this would be a horizontal translation. horizontal translation 6 right, and a vertical translation 2 up. This one, does it matter that it's a radical? No, the radical is treated like the bracket. So this is a horizontal translation 1 left. And a vertical translation 3 up. I want you to show me the mapping for each of these. Because everyone's good at the generic everything, but what they can do is they can give you mapping and ask you anything. They can give you transformations and ask you to get the equation, or mapping. They can give you the equation and ask for mapping or transformations, right? So we need to be able to do anything with any of them. So I want you to give me the mapping for all 4 of these. Okay, for this one, you're going to get x, y becomes, words and mapping are the same, so x stays the same because nothing happened to it. And we want to move my y 3 up, so I add 3. This one is going to be x, y becomes, horizontal translation 1 right. I want to move my x 1 right, so I want to add 1 to it. My y stays the same. This one, my x, y becomes, I want to move my horizontal, my x 6 right, so I'm going to add 6. My vertical 2 up, so I'm going to add 2. And then this one, my horizontal translation, I'm going to go 1 left. So I want to go x and I want to subtract 1 to make it move left. And vertical, I want to move 3 up. So I'm going to go y plus 3. Next page. So now you're given transformations and you have to come up with the actual equation. So you're going to do example 8 and example 9. You're going to give them a graph and you have to come up with the equation. So try example 8 and 9. All right, this one, horizontal translation 3 units right. So we want to move that 3 units to the right. So it has to go with the x, and you guys were taught this last year, so you have to put in brackets in order for it to be with the x, right? If not, it's with the y. So we're going to go x minus 3 squared. And last year, you guys probably forgot the squares all the time. It's just a habit to not write the 2. Vertical translation 2 up. So if it was with the x, we would actually go x plus 2 up here in the exponent. This is an exponential, which we're going to hit up later in another unit. So it's going to be by itself, and then we're going to move 2 up. Plus 2 to that. This one's a radical, which we're also going to hit up later. We do all of these. It's fun. It's just like functions forever. We just do all function brackets. We did terms and cons, and then we do polynomials, exponentials, logs, radicals, rationals, other functions, and trig. A bunch of functions, just functions everywhere. All right, horizontal translation, 4 units left. So we're going to get x plus 4, and then 3 down. Now these ones are easy because right now we can only move left and down, or left and right, up and down, right? Where we're going to add a whole bunch more to it later. So we'll enjoy these while we can. Okay, so we have to read. Which one is the transformed one? The function represented by the thick line is a transformation of the thin line. So we start here, and we have to go 1, 2, 3, 4 down, 2 right. Now remember, the original equation is f of x. So it's going to become y equals f x minus 2 minus 4. Did you get that?
Yeah.
Yeah. Most people don't spot the f of x part, and they're just like, I don't know what to make it. Okay. Or they just make an absolute value. So this one's f of x again. And we're going 1, 2, 3, 4, 5 down, 1, 2, 3 right. So we're going to get fx minus 3 minus 5. And this one is just 1, 2, 3, 4 down. So we get y equals f of x minus 4. And that is it. Everybody flip over. So remember, they always have to label their graphs, right? When they give you a graph, they have to label what it is. This one, okay. We have y equals square root x as a radical function. What vertical translation will be applied to y equals square root x so that the translation image point passes through 16, 7? So this is going to be this is the new point, right? The transformed one. We need the original, right? All right, we're back. So we need the original point, correct? They can only ask us a question like this because they gave us one translation. So they want the vertical translation. So if we only did one translation, then the y changed, but the what did not? The x didn't. Right? So that means on our new point 16.7, our original, I arrow because we're coming this way, was 16 something, wasn't it? Because if all we had is a vertical translation, our x's didn't change. And we were taught in grade 10, we're going back to grade 10 again. We always venture back to grade 10. It's a great place to be. We were taught if we're given the equation, and we're given one of the variables, we can always get the other, weren't we? By just doing what? Substituting that in, right? Substituting it in for, in this case, x. So we're going to get y equals square root of 16. So y equals 4. So there's our original point. We plugged it into our original equation. Yep.
Did we do that same we did in like grade 11 where you do like the positive and minus?
Plus or minus works if you physically take the square root. So if you went in, and that's perfect. So say you had like y squared equals x, and then you square rooted the y and you square rooted the x, then you'd go plus or minus square root of x. But if they gave us the radical right off the bat, and we didn't actually get it ourselves, then whatever sign it is what it is. So in this case, it would just be plus. Okay? So yes, if you physically take the square root, please put the plus or minus. If it's just a square root, it's just what it is. So what did we do? What vertical translation happened? Vertical translation 3 what? Don't all answer at once. Went from 4 to 7, you moved 3 up. I don't know. Sounded like a little bit of like a sneeze with an elephant or something. Or a desk moving. Maybe an elephant sneezing, moving a desk. That's what that was. What horizontal translation would be applied to y equals square root x? So the translation image passes through 17.8. So now we have a horizontal translation. So what doesn't change? The y, right? So we have 17.8. So this was something 8, right? And we plug it back into our y equals square root x, but this time we plug it in for the y. So we're going to get 8 equals square root x. How do I get rid of a square root? Square it. So 64 equals x. So it was 64. It's now 17. So that's a horizontal translation, what? Pardon? 40, what? 47. Yeah. To the? $17. Take out 1c and take out 9. You can get 17, right? Get